Okay, here we go. Quad tutorial number 17, graphing quads using transformations. So a quick little pre-note like we did last tutorial. I want us to look at what we call our parent function for quadratics. Y equals x squared is our parent function. And there are some truths to this parent function that we need to observe. First of all, that the vertex is located right there on the origin. So we are right there on the origin, and let's see if I can do that with blue. And that if we took our time and plugged in 1 for x, right, if you plugged in 1 for x, what y would equal 1. So that's why we get the 1, 1 point right here. If you plugged in -1, we'd also get, and we also know about symmetry, right? If we plugged in 2, we'd get that y is equal to 4. Right, and that explains that point, and then the symmetry gives us that point. And so what I wanted us to notice is some patterns. Yes, we know that when we're given the parent function, we're going to see the vertex right there on the origin, but we're also going to see a pattern, and that is when we move 1 away from the vertex, we always go up 1. When we move 2 away from the vertex, we go up 4. So we're going to use that knowledge of that pattern to graph these quickly. Let's see what's behind these green boxes. I'm not sure. Okay, note quads pattern. Over 1, up 1. Over 2, up 4. So that's from the vertex we're talking about. And yes, this is called the parent function. All right, so let's get to the notes. No, let's not. Lots of things can happen to the parent function. The vertex can shift, the whole graph can flip, and the graph can also become more or less steep, and you want to know how. All right, so this is important before we get to the notes. So some of you will even want to pause this after I click on all these boxes and write this down. So this is a kind of a big mess. See, all of a sudden, there's not just y's and x's, there's m's and h's and k's. We know m stands for slope. But this, let me just show you, maybe we're looking at a quadratic that looks like this. Okay, so you can see how the 4 is my m, which is my slope. It's got, quadratics do have a rate of change. They do have a slope. It's just not a constant rate of change, so that's what makes it different than the slope of a line. But this part right here, that's my h, and this part right here is my k. So we're looking at a general formula so that we can make some observations about general formulas. Okay, so here's the deal. Yes, the m, the slope, is going to affect how steep or narrow our quadratic looks like. For example, if we see something like this, y equals 5x, that's going to be steeper than our probably even more steep than that, than our parent function. See, our parent function is nice and, I don't know, it's just wider, and y equals 5x is steeper. And that's because the slope, the rate of change for a quadratic, messes with the pattern. It multiplies our pattern of over 1, up 1. Instead of going over 1, up 1, we go over 1, up 1 times 5, right? So it stretches the quadratic up higher. You see this as flips over the x-axis. If we see a negative here, that is what happens. A negative will flip our quadratic right over the x-axis. And we'll see what that looks like in just a second. Our h is in charge of the horizontal shift. So if we see a number there, that's going to make us shift left or right, or left or right. And we'll talk about that more in just a second. And k, this number way at the very end, is what's going to shift our vertex of our quadratic up or down. So I want you to notice that these two are going to affect our vertex. Our vertex might get moved to the left or to the right or up or down, and this right here affects our pattern. So we're going to be using this knowledge to graph quadratics today in a different way than we did last time when quadratics were in standard form. So let's try. So here we go. Let's look at, we're actually going to do number 2 first. Number 2 looks more difficult, but it's actually might be a little easier for us to start with. All right, I noticed 2 things. I noticed that this right here and this right here are going to shift my vertex. So I want to remember that if I'm starting out thinking about the parent function, right? Over 1, up 1, over 2, up 4. Oops, okay, yeah, it looks okay. So if I think about that, then this one, the y equals -3 times the quantity x minus 5 squared plus 6, is shifting my vertex first. So I want you to notice something. If I just had this, see this down here, this equation, see how I only have the -5? Are you shocked to see that it shifted our vertex to the right? I mean, that's crazy, right? That x minus 5 would mean that we're shifting to the right instead of to the left. Well, it's actually, if we set x minus 5 equal to 0, then we see x equals 5, right? That gives us our placement actually of where x is located. So that's why. You can, I say silly things like, oh, when you're around your x, you always say the opposite of what you mean. You're like, yeah, everything's going great. Then you cry later. I don't know. That's a silly way to remember it. But the best way is just to go ahead and remember that I'm just taking the x minus y, setting equal to 0, and solving for x. So the x minus 5 part, this part, shifts our vertex to the right 5. And then, so we already shifted our vertex to the right 5. This part, this plus 6, shifts it up 6. So note, this is pretty easy to remember. There's no x here. It's just a plain old plus 6. It's a positive 6. So far, if we're going to graph, I'm going to stop right now because I'm showing you pictures and we're like, Ms. Overby, I don't have that on my sheet. Let's graph. So the first things that we're going to be looking at, I think we need some magenta. Ooh, orange, let's see that. All right, so the first thing we're going to look at is taking our vertex that used to be here, if we were the parent function, and it got shifted to the right 5 and up 6. So we'll go to the right 5 and then up 6. Here is our new vertex. So let's erase the other stuff, right? We don't need that other stuff. I'm just showing you how we got it. We moved to the right 5 and up 6. Here's our vertex. All right, we're halfway done. We're almost done. Because the only other thing that's here that is different than the parent function of y equals x squared is all of a sudden we have something. Now we really do need magenta for this. All of a sudden we have, okay, all of a sudden we have something that's going to mess with our pattern. Da-da-da-da. We have a rate of change that's different than 1, because normally we just don't have a number there, right? See, we don't have a number, so that means normally our rate of change is 1. So we're going to be messing with our pattern. So this is what I do. I make a table, but the table looks a little different. I always know that when I go over 1, I go up 1, right? But this time, I'm going to be multiplying that up 1 by a -3. So 1 times -3 means, when I move over 1, whether it's over 1 to the left or over 1 to the right from the vertex, that means that instead of going up 1, I'm going down 3. Now look, if you don't like the way I'm doing this, 1, 2, 3, then you know what you can do? You know that you can just plug in the numbers to the left and to the right of the vertex. We did that in standard form. You guys are good at it. I'm just giving you another way to think about it because I think patterns are cool. And so to find our next set of points, I'm going to think about normally if I go over 2 from the vertex, I usually go up 4. Right? And so this time it's like, no, that up 4 is being multiplied by -3. Our pattern is being multiplied by -3, which means actually, if I move over 2 from the vertex, I'm going all the way down 12. There I go. Now, once again, can you find these points the old way that we did last video? Absolutely. Some people love working with the patterns, and some people are like, Ms. Overby, you're too much. All right, your choice, your choice. But definitely finding the vertex, this is the way to find the vertex. You're not going to do -b over 2a. Good luck with that. You'd have to do a lot of work to get this quadratic in standard form. You do not want to do that. All right, so there we go. We've got it. Let's see what's behind this one thing. Oh, multiply pattern by -3. Oops. Probably should have clicked on that earlier. All right, pause the video and get a marker board because guess what? You need to practice. All right, I'm waiting. Go get that marker board. You know, you need to pause it and get the marker board. I'll be right back, and you'll be right back. Okay, so marker board time. Here is our quadratic equation that we want to graph. What I want you to do now is pause it again. Pause it, write it down, and then when you unpause it, you're going to see the answer. So quick, 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 pause. All right, I'll see you back in just a second. Hold on, I gotta remember how to pause. Okay, so you've probably unpaused, and hopefully, gosh, let me get this equation out. Well, if I get the equation out, you're not going to be able to see. If you need to pause this and double check that you did it right, do so. I'm going to keep moving on. Please pause it and double check your work. Okay, here's another marker board one. I'm going to skip this one because the video is going to be way too long. So just know that if you want to practice this on your marker board and come find me and see if you graphed it right, that would be awesome. Okay, so let's go back and let's do number one. You'll notice that X does not have company. Okay, when we went and looked back at this long equation, X has company with the H, but X is by itself. That means that the vertex does not shift to the left nor to the right. All the vertex is shifted is up 9. So that means that we start, I'm not sure what's behind all these green things, but I'm going to go straight to the graph. Oh, all right, let's see if we can go straight to the graph. All right, so let's move this. So we're going to just start up 9. Oh. I'm going to have to move this. What is behind here anyways? Oh, multiply the pattern by 1. All right, that's going to come in handy in just a second. Boop. It's not cooperating, is it? Okay, don't make me angry. Let's just move the whole thing over. All right, so what we're going to do is let's move the vertex up 9, and there it is. All right. So what we're going to do is we're going to write on these green things. Let's see if we can. This negative messes with the pattern. So normally when we make our table, we're talking about moving over 1, right, and up 1. But this negative messes with our pattern, and we need a number to attach to this. So we're not just going to multiply by negative, but we're going to multiply by -1. So now instead of moving up, we're actually moving down. So 1 times -1 is -1. So that's going to affect my pattern and move over 1, down 1, over 1, down 1. Normally when I move over 2 away from the vertex, my pattern moves up 4. But darn it, this -1 is messing with my pattern. So I'm going to multiply 4 times -1, and I see that I have to move down 4. So we're going to move 2 to the right, down 4. 1, 2, 3, 4, and 2 to the left, down 4. 1, 2, 3, 4. Okay, once again, if you don't like this pattern thing, you can plug in these numbers in a table. You know how to do that. Okay, so I think we have a marker board one again, and so if you want to go ahead and pause that, I'm going to do it real quickly and just make sure. I promise I won't make you do the next one, so go ahead and pause, and I'll pause, and we'll come back together. Okay, so hopefully your marker board graph looks like my marker board graph. And if it doesn't, please get help from either me or one of your peers. All right, I'm going to let us skip the next marker board one. If you want to do that and double check with me, you can. All right, and the last problem on our notes, on problem 2, identify where the graph will have y values of -6. So this is very similar to a question that was asked in our standard form section of graphing quadratics. So we already know that we're going to have, if we look back at the graph, let's see. Oh my goodness, problem 2 seemed like, oh, that was the first problem we did. So let's see. We started with problem 2. Could we see, how about we take the graph with us so we can look at it. Let me sit down and come on over here, and let's just take the whole graph with us. All right, we're going to group it together, and then we're going to copy it. And then I know you guys already can see it because you've got your, you've got your notes in front of you, but it'll help me. All right, so here's the graph they're talking about, and they're wondering, hey, when will the graph have, at what x values will the graph have y values -6? Well, we already see, we did such a good job in our graph. So we already can see the answer. The answer is, well, right here, these are the 2 points. Let's see. This point is looks like over 3 down 6. And this point right here is over 7 down 6. We might not be so lucky on the test, and also they're going to want to see you work this out algebraically. So let's go ahead and work it algebraically and see if we end up with the same answer. We already know anyways that we are going to get 2 points for our answer, and that both those points are going to have the y value of -6. So that's kind of cool. Before we even start, we're halfway done. Well, at least we can think we are. All right, so here we go. If my y value is -6, that means when I see a y, I'm going to go ahead and plug in the -6. And I'm going to realize real quickly, I am going to want to solve this using square root method, because I certainly do not want to expand the binomial and distribute the -3 and combine like terms. No. So what I'm going to do is I'm going to try to get this square root part by itself. So the first thing I'm going to do to make that happen is I'm going to subtract the 6 from both sides. So it gives me a -12. And then I'm like, oh, my mission's almost accomplished. I almost have it by itself. But that darn -3 is in the way. So I'm going to divide both sides by -3. And I get 4 equals x minus 5 quantity squared. I know that to solve for x, I got to break it free from that square, right? And so I'm going to take the square root of both sides, remembering to put a plus or minus in front of my 4. So I end up with this, which is 2 equations in one. A lot more for your value, right? We got 2 equations in that one. I add a 5, so we get x is 7. Add a 5, we get x is 3. So we're going to put a 3 and a 7 into our answers, just like what our graph told us. Isn't that great when our graph and our algebraic work does match up? It's a good feeling. All right, thanks for joining me, and yeah, have fun practicing.